Standard steps for graph plotting. Standard steps for graph plotting. WAEC students, NECO, NAPTEP, GCE. This tutorial is for you. You're going to learn how to plot a standard graph, especially when it comes to your final year exams, so you can obtain the maximum result and marks, because you can be penalized. And if you fail your practical work, automatically, especially like physics, you will fail physics. Practical work is close to 40 marks because you are going to answer 2 questions. Then you should understand that 60 is what is left for OBJ and theory. So please sit up and pay attention to this. Step 1. Choose the correct variables. Choose the correct variables. That's the axis. The independent variables, the one you control, is plotted on the x-axis, as seen being displayed, and from this particular experiment, our masses are on the x-axis. So, and the values are fixed. So we have control over that. We plot that on the x-axis, although it is in the instruction. Are you following? Then, the dependent variable, the one measured, goes on the y-axis. Are you following? So the practical, the experiment carried out, is what will be on the vertical axis. And if you check, we are asked to plot t squared on the vertical axis. Okay? If it is for electricity, it will be V against I, or V inverse against I inverse, or V against R, as the case might be. Then, step 2, choose appropriate scales. Make the graph occupy at least 3/4 of the graph sheet. You can see my graph on this screen. You can see that I tried by all means to extend my graph to both edges. And then you make sure you capture 3/4 of your graph. So it means use almost everything if you want your mark to be given to you perfectly. Use simple scales like 1 centimeters is equal to 1, 2, 5, 10, not 3 or 7. It will be complicated for you. Or you can use 2 centimeters as seen on this graph. What do you see? I'm using 2 centimeters for 0.1 units on the y-axis, and I'm using 50 units for 4 centimeters on the x-axis. Can you see that? Yes, that is it. So never write 0 more than once. Start close to the origin, but not necessarily at origin. The instruction for this practical was that the graph must begin from origin, both axes. So which is why you are saying 0 there. I hope you are following. Then step 3, label the axis clearly. So what does it mean? It means what is plotted must be written or captured, and the SI unit. How to determine the value of each tiny line. This is the procedure. Okay, your 2 centimeters divided by the differences between the upper limit and the lower limit. Okay, like this is 0.2 minus 0.1, which gives you 0.1 divided by 10 lines, 2 centimeters, and this will give you 0.01. Is that taken? 0.01. So each tiny line is 0.01 on the vertical axis. You do the same thing for the horizontal axis, and then for x-axis, which is m, which is mass in grams, we have 4 centimeters, not 2 centimeters, 4 centimeters here. Okay, represents 100 minus 50 units, which will give us 50 units. So how many lines are in between? 10 plus 10, which gives us 20. So it's going to be 4 centimeters is equal to 20 lines, and is equal to 50 divided by 20. Okay, if you do that, our answer becomes 2.5. So each tiny line is 2.5. Take note of this. This will help you in solving problems when it comes to slope, in determining your intercepts, okay, and some special values. Please take note that this is not your scale, okay? This is not your scale. Now, let's proceed. Choosing appropriate scale. Make the graph occupy at least 3/4 of the graph sheet, okay? Then your scale for y and x axis must be captured as seen. For y-axis, 0.2 minus 0.1 will give you 0.1. So 2 centimeters equal to 0.1 units. For x-axis, it's going to be 100 minus 50, which gives you 50. So if you want to confirm, you can continue with the same procedure. You see that 50 is constant. So 4 centimeters is equal to 50 units on x-axis. This becomes your scale. Use simple scales: 1 centimeters, 2 centimeters, 1, 2, 5, 10 units, not 3 or 7. It will complicate issues for you. The scales on both axes must be uniform. Take note of these. Never write 0 more than once. Start close to the origin, but not necessarily at the origin. Is that clear? Let's proceed. Step 4. Plot all points neatly. When the mass was 50 grams, T squared was 0.48. Now, 0.4 to 0.5, that's where 0.48 lies. So for you to know where 0.48 is, you will now pick the difference between 0.4 and 0.5 and divide by the number of lines. Okay? So this can be 10 divided by 0.01. I hope you are following. So this will give us 0.01 times 8 will give us 0.08. If you add that to 0.4, it will give you 0.48. I hope you are getting it. So it means we are going to count 8 lines. So let's begin. In between 0.4 and 0.5, we'll count 8 lines. Let's count now. You see, the center is 5. So 6, 7, 8. So that is a point. All points must be plotted accurately using X or dot with a circle. Okay? I'm using X here to represent that. So pick this point. You may be penalized for using dots without crosses. Is that clear? Take note of that. Or when you plot outside the box lines. Now, the second one now, when our mass was 100 grams, our T squared was 0.62. We'll do the same thing. 0.62. So this is 0.6. Okay, I'll just attach 2 lines to it because I know that each line is 0.01. So that becomes our answer. Then the third one, when it was what? 150. 150 gave us what? 0.77. So let's look at our graph. 0.77 is after 0.7 and before 0.8. So that gives us 7 lines. We'll count 7 lines. Yes. And make a small X on it. From 7, you count 7 lines. The center is 5, 6, 7. So this gives us our point. Is that clear? So we'll proceed now to the next value. Our fourth value here is 200 gram mass and is 0.92. Okay, then if you check 0.92, just 2 lines after 0.9. So this gives us our answer. Okay, then the next one is 250. 250 is 1.06. So we'll move to 1 and count 6 lines. Are you here? So 250 connected to 6 lines. Can you see it? 6 lines. So we have this. Our answer is around this point. So this gives you the lines of best fit. Now, Draw a best fit line or curve. For this, we are going to draw a line. If the points fall on a straight trend, draw a best fit straight line. Is that clear? Pick at least 3. If all the 5 falls in, that is perfectly. Can you see this? You can't use this. Let's pick at least 3. Don't connect dots point to point like a child's puzzle, please. Use a perfect straight line. Can you see it? So this can give us our answer for this. So we can use this. We can go ahead and use this. From here, you can be asked to determine the point of intercept and also the slope. So the point of intercept here, if we are going to calculate for that, the intercept is the point where the line of best fit meets the vertical axis. So this is the point. And if you observe this 3.5, 0.35, 0.37. Can you see that? 0.37. So that gives us our answer for this vertical axis. And if SI unit is required, gives you t squared or s squared. Our slope is change in y over change in x, change in t squared over change in m, which is our mass. Okay, then this will give us t squared 2 negative t squared 1. So that becomes our formula. Then how to choose points? Select 2 well-spaced points on the line, not from the table. Okay? Clearly show these points with coordinates written beside them. WAEC loves when you show chosen points on the line. That can gain you up to 2 marks. So you can decide to pick any point. I hope you are following on this graph, and it will still give you your perfect answer. So this is a change in y to change in x. Is that clear? So our change in y now is 1.06 minus 0.77. Okay, 0.77, all divided by our change in mass will give us what? 250 negative 150. So that this will give us 1.06 negative 0.77 is meant to give us 0.29, all divided by 100. So that this will give us our final answer to be 1.053. That's our slope. Okay, the SIN becomes second squared over grams. Second squared over grams, which is second squared per gram. I hope this is clear. Take note of that. Now, bonus tip. What is the title of this graph? Is t squared, graph of t squared against m. I hear, but when writing, write graph of t squared in second squared, as in bracket, against m in grams. Is that clear? Now, one of the questions is determine t when m is equal to 180. So what we're going to do is that we're going to locate 180 from the graph. 180 is in between 150 and 200. How are you going to do that? If you look at 150 and 200, we have 20 lines. So the differences is 200 negative 150, which is 50. Now 50 divided by 20 lines will give us 2.5. Are you here? So how many 2.5 are we going to add to 150 to obtain 180? Are you here? So you are going to do your mathematics. Your calculator should be close. 2.5 times 10 will give us what? Will give us 25 plus 150 to give us 75. Okay, which is 175. Then 2.5 times 12 will give us 30 plus 150 is 180. So this is perfect. So 12 lines. Okay, so if you attach 12 lines to 150, where are we stopping? Look at it. We'll stop somewhere here. So we're going to use a straight line okay, and connect this straight line to our line of best fit. So we're going to draw this straight line to connect to the line of best fit. So let's trace it upward. If we do that, let's do that upward, yes. Then you connect it to your vertical axis, okay? Connect it to your vertical axis. Let's do the same thing for vertical axis. You now draw and connect. Can you see that? If you look at this, it's not giving us a perfect line. So let's reconnect it. Let's reconnect. If we reconnect, it's giving us what you are seeing now. So our answer becomes 0.85 plus 2 gives us 0.87. 0.87. So when the mass was 180 grams, our T squared was 0.87. I hope you are following. Take note of this. It's not T inverse, please, but T squared. Is that clear? Finally, bonus tip, WAEC NECO examiner tips. Use pencil for everything. Your graph, your labels, your line. Use a very sharp pencil. Never skip the origin. If the scale starts elsewhere, use broken axis. Is that clear? Label at least 3 to 4 values on each axis. Then ensure your graph is neat, is large, and readable. Okay? Then don't shade areas. You are not an art exam student. Take note of that. This is physics class. So that is that for this particular tutorial. If you enjoyed this tutorial, please, you can encourage us by liking this video and sharing with your friends, and also watching other tutorial videos. Thank you, and wishing you all the best in your exams. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.